Hello, today we're going to do a tutorial on Keil microvision, one of the IDEs that we're going to be using during the course. We're going to open up a new project, create a new project. We're going to add some files to it. We're going to put that code into our device. We're going to debug the code, and we're going to look at some issues related with all those. We're not going to go into the programming details. That's going to be done in the class, but this is just an introduction to you to use the Keil with the assembly language. So let's just get started. The first thing that we want to do is start up Keil from the device that you're using, computer that you're using. The microvision Keil interface is in front of you, and you start up a new project as a new microvision project, as you see here at the top. Okay, so click on that and then just type in a name for that. Let's call it my tutorial. So my tutorial has been generated with you have to add some targets to it, so you select your own chip from here. My chip is STM32F303 RET. I click on it, I say OK, and I move into the different environment setting window. And from this runtime environment settings, you have to click on two things. One is the CMCA-SIS button, which you have to select the core, and this has to be selected. Also from here you have to select another thing, which is the device, and from here you have to click on startup. So startup has to be selected, but as you see there are some yellow colors that warns you about some missing components from this environment, which is going to be resolved once you click here a resolve button at the bottom. So as you see, everything is fine. It's all green, but another component, which is STM32CubeMX, has been added to that environment. That means you have to add also STM32CubeMX. You have to install it, and once you start up that CubeMX, let me make sure I started it. It fires up CubeMX. It takes a while to load some parameters for your device. Actually, it loads up a lot of HAL libraries, which are very essential for STM32. But since we are not going to do any C programming at this time, we won't be needing any of those. But this is needed for starting up an assembly code, just for some initializations of the memory spaces and starting up some procedures and things like that. So what you have in front of you is the chip itself. All you have to do, since we're going to be doing we're not going to be doing any C programming, we're just going to be doing assembly language programming. We just do a generate code here to load up those libraries into our Keil environment. So we just wait until these are transferred to that environment. So we just wait, and when it's done, we just close this part, close this interface of STM32, and once we're closing that, I guess we open that when we say OK, we have the target generated underneath my tutorial. So as you see, we have included CMSIS core component, and we have the device files that we just moved from the STM32 CubeMX. So those are going to be here along with a startup file, as you see at the bottom here. That has to be there. So when we double click on that, it's going to open up, and as you see, all the details about our low level details about our code is going to be available at this moment, such as the stack size, such as the heap size, such as the vectors, And the most important thing here is the code that we want to run has to be here. So it has to be imported from our code. As you see, there's an import main here, which is going to correspond to the function name of the assembly language that I want to run. So I'm going to have main code initiated from this point on. Since I don't have any other procedures in my code, this is going to be the only line I will be needing, and that's just going to be loaded over here, and it's just going to be started at this moment. Now let's get back to the top of the code over here into source group icon, and from the source group I'm just gonna be adding the file that I would like to run. You can create a new item, new file here, new assembly language code here, or what you can do is you can use one of my codes in the GitHub page to get you started faster. So you can just add an existing file from this line. That's going to take you to another window. I just load one of my files over here. I just added that. As you see here underneath source group 1, I have a new file called mytest.s. I double click on that to see what is inside. I see that that's my file for the assembly language. I make some initializations for the port A, and I turn on an LED, I turn off an LED. In between there are some delays. So we're gonna just look at these stuff in the class, but this is the code that I want to run. Where is my delay, by the way? This delay interval is the delay that I want to go with in between those flipping of the LED on and off. So easy. At the top of the window I just click the project, I find build target, I click on build target, the target is being built. As you see, for your initial run you might get a lot of warning messages. That's okay. You can also turn those off. These are mostly from warnings from your unused HAL libraries. If you rerun that, if you rebuild that rather, those are going to be eliminated. So you're going to have to end up with 0 warnings, 0 errors. If there are some errors or warnings, you have to make sure that they are gone. Okay. So at this moment, what you do is you can download this code into your device. But before you do that, I urge you to click on this options for target, as you see at the top over here. So that's very critical you do that. So once you do that, it opens up a new window, as you see here. And in this window, we have the device name. You have to confirm that your device is correct. Your target is there. Your target is there. You're using the right compiler. And another thing that you have to check is that debug tab. Click on that debug tab and make sure that you're using the correct debugger for your purposes. So make sure it is ST-Link debugger if that's the debugger that you're using on your board. So that's a board related stuff. You have to make sure that it's correct. So ST-Link debugger has to be set. Other than that, check out its settings and make sure your debug adapter is here in the slot and its serial number is seen. That shows you that you are actually you have actually connected your device correctly onto your computer. Okay, so for the debug part at the bottom over here, you see there is a window that says connection normal. I would rather set that as under reset. That gives some more delay for connection. So if you're having some problems, just make this under reset to make sure that your device correctly downloads your stuff. So once you do that, you just click OK and then come back to up here. That is a load button over here, or you can just press F8 to download your code to your device. If everything goes correctly, you'll see that your device just flickers a little bit, and then you have your indication at the bottom of your interface. It says verify OK, flash load finished. Everything is fine. So that means you have downloaded your code correctly. What you have to do is you have to click on the reset button, make sure that your device is actually working at this moment. Now, what we said that we're gonna look also into the debug session. You have to click on this button at the top. That's the start stop debug session button. Start up that debugger session. It just opens up a new interface that takes you to where the registers are on the left hand side, as you see here. So you can in real time monitor what the registers are. You can also see the contents in the memory, as you see, and each line is going to be your code line, and you can also visualize them in detail, in greater detail than the assembly language code. So this is very nice. You can also open up other windows that you can also visualize the memory contents, things like that. You can all do that through this interface while you're debugging it. Now, I would recommend you to go into your code and see, for instance, at this moment when you turn on LED, what line that corresponds to. So that's basically a move instruction with the right encoding of that instruction, what that corresponds to in terms of an opcode, an operand, things like that. You can actually visualize it at the top in the disassembly portion. Now you can say that I can run up to that point, so why don't you go up here and click a point in your code and then go to this point at the top that says run to cursor line, as you see here. So once you do that, it goes to that line, and as you see, you can visualize the contents of the registers. While you do that, you're at this line at this moment, and you see that what the contents of the registers are at this moment. You can go step by step by doing a step over per each instruction. It's another button at the top, step over, and you can go step by step through the lines. As you see, once I click that, the content in R3 is this 20 hex, and you can come here and verify that R3 content is actually 20 hex once you clicked on that button. So that's a good exercise for you to actually see how the code actually is manipulated through these lines. And what you can do is you can come down here, you can see an LED blinking. Once I come here, this is a super loop, so it has to go back to the beginning of the loop over here continuously. So I go to this line, I run my code up to this line. As you see, I ran my code, I turn my LED on and turn my LED off, and every time I do that, I can see the LED blinking. Okay, so that was actually a short tutorial that hopefully helped you to get started with your code and see how you can do it. Okay, thank you for watching. See you later. Bye bye.